Hello students, now I am going to discuss Cambridge O-level chemistry October-November 2023 paper 22 paper 2 October-November 2023 paper 22 paper 2. Please subscribe, like and share my channel. Let's move. Here some compound list is given: ammonia, ethanol, glucose, magnesium chloride, magnesium oxide, methane, nitrogen dioxide, phosphorus 5 chloride, polyethylene, sodium bromide and water. Now you are asking, each compound may be used, these compounds may be used once, more than once or not at all. I identify the compound that is a waste gas from digestion in animals. This answer will be methane. Is come from digestion in animals, rotten things, methane gas produce. B, turns blue litmus, blue cobalt to chloride pink. And this, you know, this is the test for water. Water turns anhydrous cobalt to chloride blue to pink. So this is the test for water. C, reacts with ethene above 100 degrees centigrade to produce ethanol. Answer will be water. And you know, ethene reacts with steam to produce ethanol. So above 100 degrees centigrade water forms steam. So above 100 degrees centigrade, above 100 degrees centigrade water become steam. So ethene reacts with steam, I mean water gas, to produce ethanol. D, is a product of photosynthesis, and you know, photosynthesis, glucose is produced, glucose and oxygen are the product. So here glucose is the product. Now contains an anion with a charge of -2. You know, magnesium oxide, MgO, here magnesium +2, oxide -2. So magnesium oxide will be the answer. Now next, number 2, this question is about metals. So chromium is a transition element, sodium is an element in group 1. State 2 physical properties of chromium that are different to those of sodium. Chromium, you know, chromium is a transition metal. So number 1 will be high density. Transition metal has high density and also higher melting point. Transition metal has high melting point, but sodium has low melting point. These are the different. Now B, deduce the number of protons and neutrons in chromium atom. Here chromium number of proton is the 24 atomic number proton, and number of neutron will be mass number is 53 minus proton number 29 is the number of neutron. Now chromium 3 oxide reacts with carbon and chlorine to produce chromium 3 chloride and carbon monoxide. Construct the symbol equation for this reaction. You know, this is the chromium 3 oxide reacts with carbon and chlorine, chromium 3 chloride and carbon monoxide is produced. So here 2 chromium, so I write here 2. Now chlorine 3 to the 6, so if I write here 3 to the 6 chlorine. Now oxygen here 3, so I write here 3. Carbon 3 on the 3, so carbon will be 3. Balance equation. D. Complete the diagram to show the electronic configuration of sodium ion. You know, sodium ion has 10 electrons, sodium plus. So first shell has 2 electrons, second shell has 8, total 10, and sodium has 1 electron, so it loses to form plus 1 or only plus. Sodium has 10 electrons, first shell 2 electrons, second shell 8, and this become positive ion plus 1. Now this is from reactivity series. You are asking some metal is given and their observations are given. When 4 different metals heated in oxygen, this metal heated with oxygen and observations are given. So now you are asking put the four metals in order their reactivity, and put the least reactive metal first. So first least reactive, most reactive, and you see first sodium burns rapidly, so sodium is the most reactive, and mercury does not form an oxide layer on the surface, so it is the least reactive. Now nickel and lanthanum, nickel is the less reactive compared to lanthanum. Why? You see, nickel forms a oxide layer slowly, but lanthanum forms a oxide layer rapidly. So lanthanum is more reactive than nickel, so this will be nickel and this will be chromium. These are reactivity increases: most reactive sodium, least reactive mercury. F. Aluminum is used in food containers and overhead electrical cables because it is resist to corrosion. Now, 1. Explain why aluminum is resist to corrosion. You know, aluminum forms an oxide layer which stop oxygen getting in. I mean, aluminum reacts with oxygen to form a strong coating of aluminum oxide which does not allow oxygen getting in or oxygen enter, or you can write which stop getting in acid or water. Now state 2 other reason why aluminum is used in overhead electrical cables. Why these are used? High electrical conductivity, their conductivity is high, electrical conductivity is high, so that's why these are used. And it has low density, density is less, low density. Next, a student investigates the reaction of large pieces of calcium carbonate with dilute hydrochloric acid at 20 degrees centigrade. The hydrochloric acid is in excess, so hydrochloric acid is excess. Now complete the equation for the reaction by adding state symbols. Calcium carbonate is a solid, hydrochloric acid aqueous, calcium chloride given aqueous, water liquid, carbon dioxide gas. Now this deduce the volume of carbon dioxide gas released after 40 seconds. You will get answer from graph 34. How you get after 40 seconds? You count it. So 40 seconds is this. You will this point. So 34 value is just from here. Volume of carbon dioxide is 34. Next, the student repeat the experiment using the smaller pieces of calcium carbonate, small particles. So all other conditions stay same. Draw a line on the grid to show how the volume of carbon dioxide changes when smaller pieces of calcium carbonate are used. And a smaller particle or smaller pieces have greater surface area, so rate of reaction will be faster and graph will be more steeper compared to the others. So this is the when this line will be more steeper when small pieces of particles is used, but total volume of carbon dioxide will be same. Graph will be more steeper, but total volume will be same, because rate of reaction is high when small particles, surface area greater, so rate of reaction is high and graph is steeper. See, the student repeat the experiment at 20 degrees centigrade. All other conditions same. Describe and explain using the collision theory how the rate of reaction differs when the temperature of 20 degree is used. And you see, previous temperature was 25 degrees centigrade. You see here, previous temperature was 20 degrees centigrade, now 20, decreasing temperature. And decreasing temperature, rate of reaction will be decreases. So your answer will be rate of reaction decreases as 20 degrees centigrade temperature is less than 25 degrees centigrade. So rate of reaction decreases. Why? Particles have less kinetic energy. Particle has less kinetic energy, so fewer successful collisions occur per unit time. I mean, rate of reaction decreases because temperature is less, so particles have less kinetic energy, so less successful collisions occur per unit time. That's why rate of reaction decreases. And D, a sample of carbon dioxide is put into a gas syringe. The end of the gas syringe is then blocked so that no gas can escape. Now explain using kinetic particle theory why increasing the pressure in the gas syringe decreases the volume of gas when the temperature stays same. If you increasing the pressure, volume decreases because particles become closer, the particles are closer together, that's why volume decreases. Now number 4, concentrated aqueous magnesium iodide is electrolyzed using graphite electrodes. Predict the product as at each electrode. So anode, iodide ion oxidized to produce iodine, and at the cathode, this is aqueous, so when it will be aqueous, at that time at the cathode hydrogen ion gains electron to produce hydrogen. At the cathode product will be hydrogen, at the anode product will be iodine. Now molten magnesium iodide is electrolyzed using graphite electrodes. Construct the ionic half equation for the reaction at the cathode, at each electrode, I mean at the cathode and at the anode, when molten magnesium iodide is electrolyzed. And at the anode, iodide ion lose electron, minus means loss electron, to form iodine. Or you can write left side minus electron means right side you can plus, same thing. And at the cathode as molten, so as molten, if molten magnesium iodide, if molten metal ionic compound, at the cathode metal will be produced. So at the cathode magnesium ions gains 2 electron to produce magnesium. Magnesium ion gains 2 electron to produce magnesium. But when aqueous, then hydrogen will be product at the cathode. When molten, metal will be, I mean magnesium will be product. Now describe a test for aqueous iodide ion. Include the observation for the positive test. And iodide ion test, I mean halide ion test, reagent nitric acid and silver nitrate solutions are added, yellow precipitate is formed. So you confirm that this is the test for iodide ion. Reagent nitric acid and silver nitrates are added, yellow precipitate is formed. Next, iodide ion reduce manganese 4 oxide to manganese 2 ions. Iodide ion manganese 4 oxide reduced to manganese 2 ions. This is the manganese 2 ions. This is the manganese 4 oxide. Here manganese oxidation number 4 plus 4, here plus 2. Now you are asking, explain in terms of movement of electrons how iodide ions act as a reducing agent in this reaction. Reducing agent means reduces another substance but itself oxidizes, means it reducing agents lose electron. So iodide ion gives electron to the manganese in magnesium 4 oxide. So iodide ion lose electron, iodide ion gives electron, lose electron, that's why it works as a reducing agent. To state the name of type of reaction that involves simultaneous oxidation and reduction, this is known as redox. Simultaneous oxidation reduction means one electron is oxidized and other element is reduced. That reaction is known as redox reaction. Simultaneous oxidation and reduction reaction is known as redox reaction. Now phosphorus triiodide PI3 is produced when phosphorus reacts with iodine. To show the dot and cross diagram for a molecule of phosphorus triiodide, phosphorus 3 iodine. Now phosphorus is a group 5 element, so it has 5 electrons in its outer shell. So it gives here 1, 2, 3. So remaining 2 non-bonding electron or lone pair electron. Now iodine is a group 7, so it has 7 electrons in its outer shell. If it give 1 electron here, 2, 4, 6 remaining non-bonding electron, lone pair. Every iodine 2, 4, 6, 2, 4, 6. Next, okay, now 5. Figure 5.1 shows displayed formula of compound A. This is a carbon-carbon double bond alkene and alcohol. 2 functional group here. So now on diagram, draw a circle around the functional group that reacts with aqueous bromine, and alkene reacts with aqueous bromine to form dibromoalkane. This is the test for alkene. So this carbon-carbon double bond circle. Now to describe the color change when excess compound A is added to a few drops of aqueous bromine. The aqueous bromine is test for carbon-carbon double bond, I mean alkene. So aqueous bromine color will be orange. When it reacts with carbon-carbon double bond, orange bromine solution become colorless. So color after addition of A will be colorless. Now deduce the molecular formula of compound A, and molecular formula shows whole ratio of atoms, total number of atoms, and you count here how many carbon, 1, 2, 3, 4 carbon, so C4. Hydrogen 3, 4, 5, 6, 7, 8 hydrogen. Oxygen 1. So C4H8O will be molecular formula of compound A. Now compound A is liquid at room temperature. Describe the motion and separation of the particles in liquid, solid, liquid, gas. So this is the liquid motion. Just sliding over each other, they can slide. Separation, liquid particles are close together, motion, they can slide or they can move very short distance, just they can slide. Motion, sliding over each other. Separation, close together. Now B, figure 5.2 shows the structure of compound B. This is butene, 2 butene, 1, 2, 3, 4 carbon alkene, and second carbon contain double bond. So this is butene. Now you are asking compound B is polymerized. Draw 2 repeat units of polymer form when compound B is polymerized. This compound polymerized, we have to show 2 repeat units. So this plus same thing here. So now you see addition polymers always happen when carbon carbon double bond. So carbon carbon double bond becomes single bond, and you see left carbon contain one left carbon has hydrogen, so you write hydrogen below, and also CH3 above. Now you count right carbon has one hydrogen, you above you one hydrogen, and one methyl group, you write here methyl. So this is one repeat unit. Same thing another repeat unit, this is 2 repeat unit. Now see, describe 2 environmental challenges caused by the disposal of plastic. And if you this landfills, if you throw plastics, this lands fills, one problem. And formation of toxic gases during burning, if you plastic burn, toxic fumes or harmful gas will be produced. Or you can write accumulation of plastic in oceans, they deposit a large amount in ocean. Okay, now next 6, steam reacts with carbon monoxide to produce carbon monoxide. Steam reacts with carbon to produce carbon monoxide and hydrogen. The forward reaction is endothermic. So explain in terms of bond making and bond breaking why this is an endothermic. And endothermic means energy absorbed or heat energy taken in. Now bond breaking is endothermic. To break bond, energy is needed, so it is endothermic. And bond making is exothermic. When bond form or make, energy is released, that is exo. As the reaction is endo, I mean in this reaction more energy is absorbed than released, or you can write more energy is needed than released. Need more, release less, that's why extra energy is needed, that's why this reaction is endothermic reaction. And 2, the transfer of thermal energy in a chemical reaction is called enthalpy change. Write the symbol for an enthalpy change. So include the sign for an endothermic enthalpy change. So endothermic plus enthalpy change del H plus del H. B. Carbon monoxide, water and carbon dioxide are formed during the incomplete combustion of carbon containing fuels. Name one other substance formed during the incomplete combustion of carbon containing fuel. So here carbon may form or particulates. You can write carbon or particulates. To state one adverse effect of carbon monoxide, and carbon monoxide is a toxic gas or it is a poisonous gas. See, hydrogen is used in hydrogen oxygen fuel cell. Describe 2 advantages of hydrogen oxygen fuel cell compared with the gasoline petrol engine. And hydrogen fuel cell means hydrogen fuel burn in oxygen to produce water. Water is the only product. plus heat, and plus heat is produced. So advantage, water is the only product, no carbon dioxide produced. Water is environment friendly product, and this efficiency is high efficiency hydrogen oxygen fuel cell. Now number 7, dilute hydrochloric acid reacts with sodium carbonate. Acid reacts with carbonate, salt, carbon dioxide plus water. Now a student titrates, do titration 20 centimeter cube of 0.02 mole per dm cube aqueous sodium carbonate with dilute hydrochloric acid using methyl orange indicator. Sodium carbonate volume is given and concentration is given. A volume of 15.5 centimeter cube of dilute hydrochloric acid react exactly with 0.02 mole per dm cube aqueous sodium carbonate. Hydrochloric acid volume is given 15.5 centimeter cube. You are asking calculate the concentration in mole per dm cube of dilute hydrochloric acid. So as sodium carbonate volume and concentration is given, so you can calculate moles of sodium carbonate concentration times volume. 20 centimeter cube divided by 1000, it has been converted to dm cube. This is mole, 5 times 10 to the power minus 4, or you can write 0.0005 mole. And sodium carbonate 1 mole, hydrochloric acid 2 mole. So sodium carbonate ratio hydrochloric acid 1:2. I mean hydrochloric acid mole is the double of sodium carbonate. So moles of hydrochloric acid, moles of sodium carbonate times 2, you get this value 1 times 10 to the minus 3, or you can write here 0.001 mole. Now concentration of hydrochloric acid, you know N equals CV. C means concentration equal number of mole divided by V means volume. So number of mole 0.001, volume is given here 50.5 centimeter cube divided by 1000. It has been converted to dm cube. So this is the answer. .0645 mole per dm cube is the concentration of dilute hydrochloric acid. 0.0645 mole per dm cube. B1, state the color of methyl orange in indicator. You know methyl orange in alkali, this is yellow, acid red, neutralization orange. So as it is alkaline solution, so this color will be yellow, acid red, neutralization orange. Two, write the formula of the ion present in aqueous solution of alkali. Alkali hydroxide ion OS minus ion is produced in a alkali. Number C, calculate the volume measured at RTP room temperature and pressure of carbon dioxide produced in centimeter cube when 2.65 gram of sodium carbonate reacts with excess hydrochloric acid. So you are asking volume of carbon dioxide, you will measure, calculate, but in question given 2.65 gram of sodium carbonate. Sodium carbonate mass is given, so you can use solid formula to calculate moles of sodium carbonate. Okay, first of all, moles of sodium carbonate mass divided by sodium carbonate molar mass 106. How you get 106? So this is the MR, relative molecular mass of sodium carbonate. 2 sodium 23 times 2, 1 carbon 12, oxygen 3 16 times 3, total you get molar mass 106. So moles of sodium carbonate mass divided by molar mass 0.025 mole, and you see moles of sodium carbonate and moles of carbon dioxide equal, I mean 1:1. So moles of sodium carbonate will be same as moles of carbon dioxide. So moles of carbon dioxide will be same 0.025 mole. Now volume of carbon dioxide, number of mole times molar volume. Molar volume 24,000 centimeter cube or 24 dm cube. But here question is asking you to find out the moles in centimeter cube. That's why volume of carbon dioxide, number of mole of carbon dioxide into molar volume times molar volume, you get 600 centimeter cube. This is the answer. Now D, hydrochloric acid. Hydrochloric acid is a strong acid. Define the term strong in the phase strong acid. You know strong, completely ionized in aqueous solution. Strong acid means the acid which is completely ionized in aqueous solution. A strong acid completely ionizes in aqueous solution. E, oxides of nitrogen contribute to acid rain. 1. State one other adverse effect of oxide of nitrogen. Photochemical smoke. Nitrogen oxide reacts with unburned hydrocarbon to produce photochemical smoke, or you can write respiratory problems. You get also mark. Now 2. Oxides of nitrogen are removed from car exhaust by catalytic converter. Complete the symbol equation for the removal of for the reaction that occur in a catalytic converter. Catalytic converter, carbon monoxide is a harmful gas, nitrogen monoxide is a harmful gas. Catalytic converter reacts to harmful gas, convert nitrogen and carbon dioxide. They convert more harmful gas to less harmful gas or non-harmful gas. Carbon monoxide reacts with nitrogen 2 oxide or nitrogen monoxide to produce nitrogen and carbon dioxide. Okay, now next. The equation number 8, the equation between carbon monoxide and hydrogen at a temperature in a closed container. This forward reaction is exothermic reaction. Delta H is negative. This is an exothermic reaction. So predict and explain the effect, if any, on the position of equilibrium when the pressure is increased and the temperature remain constant. What will be the effect on the position of equilibrium if the pressure is increased? So left hand side 1 mole, 2 mole, 3 moles, right hand side 1 mole. Pressure is increased, so equilibrium will go to left to right. Position of equilibrium moves to the right, I mean left to right, as there are fewer moles of gas on the right hand side of the equation. There are less number of gas molecules or moles on right hand side. Now predict and explain the effect, if any, on the position of equilibrium when the temperature is increased. Temperature is increased and pressure constant. This reaction is exothermic. Delta H is negative. So as temperature is increased, it will go to the endothermic direction, I mean right to left, to the left. Position of equilibrium moves to the left, I mean right to left, because the forward reaction is exothermic reaction. So if you increase temperature, equilibrium will move to the endothermic direction to absorb heat or to reduce temperature. That's why increasing temperature, equilibrium will move to the left, because forward reaction is exothermic reaction, or you can write reverse reaction is endothermic reaction. Now B, methanol reacts with ethanoic acid to produce an ester. Name the ester and draw the displayed formula. Methanol CH3OH, methanol, this is the alcohol part, and ethanoic acid, this alcohol will lost OH group, acid will lost only hydrogen, so water will be produced, and ester will be methyl ethanoate. This part is acid part, this is alcohol part. Methyl come from methanol and ethanoate come from ethanoic acid, so ester name will be methyl ethanoate. This is the displayed formula. Displayed formula means you will show all bonds present in molecule. Displayed formula. Now methanol is a member of alcohol homologous series. Describe two general characteristics of a homologous series. You can write have the same general formula, and homologous series have same general formula and same functional group. You can write have same general formula, same functional group, or you can write differ from one member to another by a CH2 group, or neighboring member are different by a CH2 group. One is differ means different, one is different from the next by a CH2 group. And or you can write trend in physical properties, or you can write similar chemical properties. These are the characteristics of homologous series. Now number 9, this table shows melting point and relative electrical conductivities of three elements: calcium, carbon and iodine. So you see melting point calcium 834, diamond carbon is very high, 3550, iodine very low melting point, and thermal electrical conductivity, calcium is good and it is metal, diamond poor, there is no free electron, and iodine is poor, this have no free electron. Now you are asking, use ideas about structure and bonding to explain the differences in the melting point of diamond and iodine. You have to explain differences. This is the diamond and this is the iodine. You see, diamond has high melting point than iodine. Diamond has a high melting point because it is a giant structure of covalent bonds. Diamond is a giant covalent structure. There are a strong bond between all the atoms. Diamond is a giant covalent structure. There are strong covalent bonds between all the atoms. That's why diamond has high melting point, melting temperature. But iodine has a low melting point. You see, iodine only 140 degrees centigrade boiling point. Why low? Because there are weak forces between the molecules. In iodine molecules there are weak forces between, there are weak intermolecular forces, or you can write there are weak van der Waals forces between molecules. That's why iodine has low melting point. Number 2, the differences in the electrical conductivities of calcium and iodine. You see, calcium is a good conductor, but iodine is a poor conductor, diamond also poor conductor. Now you see, calcium is a good conductor. Why? Calcium has mobile electrons, calcium has free electrons, that's why calcium is a metal has free electrons, that's why these are good conductor. And iodine is a non-metal, it has no mobile electron, or each electron are in fixed, there is no free electrons. Now B, diamond and graphite are different forms of carbon. Explain in terms of its structure why graphite is a lubricant. Graphite is a lubricant, and you know, in graphite atoms are arranged in layers. In graphite the atoms are arranged in layers. There are layers of atoms in graphite, so these layers can slide over each other. Graphite is a layers of atoms, so the layers can slide over each other, so that's why graphite can be used as a lubricant. Now a compound of sodium, iodine and oxygen contains 11.62% sodium, 64.14% iodine and 24.24% oxygen by mass. Deduce the empirical formula of this compound. So at first you write sodium, iodine, oxygen, their percentage 11.62, 64.14, 24.24. First you will do divided by their AR. AR means relative atomic mass. So sodium 23, this value you will get from periodic table. Sodium relative atomic mass 23 and iodine 127, oxygen 16. First you will divide their percentage by mass by their relative atomic mass. You will get this value, this and this. After that you will divide by the smallest one. These three values, 0.50 is the smallest. So if you divide by all values by smallest one, you will get this 1. How? 0.505 divided by 0.505, you will get 1. This also 1. This 3. 1.515 divided by 0.050, you get 3. I mean here sodium 1 atom, sodium is 1 atom, iodine 1 atom, oxygen 3 atom. So this empirical formula will be NaIO3, NaIO3, sodium iodate, sodium iodate. Okay, thank you dear students.